Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you very much. I'm Philip Emeagwali. In 1989, I was in the news headlines for discovering practical parallel processing as the vital technology that will underpin every supercomputer. My discovery of practical parallel processing that occurred on the 4th of July 1989 was the cover stories of oil and gas industry publications. Parallel processing was a newsworthy scientific discovery because it is the vital technology that will enable the petroleum industry to solve a grand challenge problem. Without parallel processing, a grand challenge problem could take 30,000 years to solve on a supercomputer that is powered by only one processor. I discovered that with parallel processing, a grand challenge problem could be solved in just one day and across a new internet that is a new global network of 1 binary million processors. When I began supercomputing back on June 20, 1974 at 1800 Southwest Campus Way, Corvallis, Oregon, United States, parallel processing was then considered theoretical. The technology was mocked, ridiculed, and dismissed as a huge waste of everybody's time. Parallel processing was the beautiful theory that lacked an experimental confirmation. But on the 4th of July 1989, parallel processing became reality and became so because I discovered it across a new internet that was a new global network of 64 binary thousand processors. My discovery made the news headlines because the radically different technology called massively parallel processing called for a significant change in how we compute and how we solve the toughest problems arising in mathematics and physics. Parallel processing was a paradigm shift from one processor processing alone to millions upon millions of commodity off-the-shelf processors supercomputing together and doing so to solve grand challenge problems arising in science and engineering. Without parallel processing, we will only know what might happen. With parallel processing, we know what will happen. The petroleum reservoir simulator is used to hindcast the outcomes of various crude oil and natural gas recovery scenarios. Because the production oil field is often 1 mile deep and the size of a town and has variable properties such as permeability and porosity, that oil field had to be simulated across a parallel supercomputer that occupies the space of a soccer field. The leading commercial petroleum reservoir simulators include CMG, the acronym for Computer Modeling Group. It includes Eclipse of Schlumberger, that is the industry reference reservoir simulator, that is used for black oil compositional, thermal, and streamline reservoir simulations. Eclipse is the acronym for Exploration Consultants Limited's implicit program for simulation engineering. The leading commercial petroleum reservoir simulators include Intersect, the high-resolution reservoir simulator of Schlumberger and Nexus Halliburton. The leading in-house petroleum reservoir simulators include Empower of ExxonMobil, the modular reservoir simulator of Shell, the parallel oil, gas, and water-enhanced reservoir simulator of Saudi Aramco, and the PSIM of ConocoPhillips. Parallel processing is the vital technology that makes it possible to execute the extreme-scaled computations that is the mathematical precondition to understanding the motions of crude oil and natural gas that flows across a subsurface hydrocarbon reservoir. Parallel processing makes it possible to model an oil field and do so at the microscopic rock pore scale to an oil field that is the size of a town, and even to the entire Niger Delta oil fields of the southeastern region of Nigeria. Parallel processing will make it possible to re-examine the abandoned oil fields in the Niger Delta region of Nigeria and to re-examine them under a new microscope, namely the billion-dollar supercomputer that can pinpoint new deposits of crude oil and natural gas that were formerly infeasible to recover. Parallel processing changed the way we search for and recover otherwise elusive crude oil and natural gas. I visualized a petroleum reservoir as a large sponge that is buried 1 mile deep, that is the size of a town, that is filled with crude oil and natural gas that were formed 1 million years ago. Before the 1950s, only about 10 to 20% of discovered crude oil can be recovered and extracted by using primary oil recovery techniques. By 1956, the year the first oil field was discovered in West Africa, an additional 10 to 20% of that discovered crude oil can be recovered and extracted via a secondary oil recovery technique, namely injecting water into the production oil field. New techniques and technologies called tertiary oil recovery techniques that were invented since the 1970s to present make it possible to recover up to 50% of the crude oil discovered.
Insightful and brilliant lecture.